Hello and welcome to our new Year 7s. My name's Miss McDonagh and I'm second in maths at the Archer Academy. Here at the Archer Academy we do super starters, and super starters are a fun and engaging way to get our brain ready for learning at the start of a lesson. I'm going to introduce you to a puzzle which we use in maths, and it's called the Ken puzzle. It works very similar to Sudoku, except more maths is needed. As you can see, the grid on the left is a 3 by 3 grid. That means the numbers 1, 2, 3 in any row or column could only be used once. No number should repeat in row or column. I start off by having a look here at these with a singular box that's labelled already as a 3. And I've also got a singular box labelled already as a 2. That means that this box is a 3 and the other box is these straight in. Once I've done that, I now have a look elsewhere. The 3 plus means these two boxes have numbers in that add together to make 3 in any order. So I need to use 1 and 2 in this box. So in order to figure out which one goes where, I have a look at what I've already got on the board. And if I look here, I already have a 2. As this column already has a 2 in it, this cannot be a 2. So my 2 has to be there. As a result of that, it has to go my 1. As you can see, it goes 1, 2, 3 across the top. I've got this square here. And in that column, I've got a 1, a 2, so this box here must be a 3. I'm going at this column here. It's got a 3 in it, so I know the other two numbers are going to be a 2 or a 1. And if I have a look, it says divide to give me the answer of 2. So in this box, either box is going to be 2 or 1. What I now need to look at is I look across, and as you can see, this corner has a 2 on it. This cannot be a 2. Therefore, up here is a 2, must be a 1. As you can see, that column has 3, 2, 1 going down. I now look here, and I'm looking at the row that goes across. It's got a 2, it's got a 1. This box must be a 3. On this one here, I've got a 3, a 2, so this middle box, the centre box, must be a 1. This works very similar to the Sudoku puzzles, except there is a little bit more math involved when we are selecting our answers. Try again and see if we can follow this one. I first of all look to see if there are any singular letters which are blocked off. As you can see in the corner, there is one with just a 3. This means that this box is going to be a 3. Have a look in this box here. This tells me that the two numbers divide to give me the answer of 3. Out of the numbers that we have, that means it must be the numbers 3 and 1. As we've already got a 3 in the far right column, my 3 has to be in the centre, which means the other box has to be the 1. Let's now have a look at the top. I've got this column. It's got a 3, a 1, and what number is it missing? It's missing in its row a 2. In this row going across, I've got a 3, a 1. What number am I missing? It's a 2. Here it tells me that the two numbers divide to give me the answer of 2. Remember, these can be in any order when you are performing these. two numbers that divide to give me the answer 2 are going to be 2 and 1. This box here must be a 1. Across the whole of the row, I've got a 2, a 1. My final box has to be a 3. I look down and I've got here a 3 and a 2, so this box must be a 1. 3 and a 1, so this box must be a 2. Here is one for you to try yourselves at home. Okay, so now we're going to have a look at the product of primes. We're going to draw factor trees, write numbers as a product of its primes. To begin with, we're going to have a look at these factors of 30, and we're going to discuss if they're prime and a factor, if they're not prime and a factor, or if they're not even a factor of 30. So lots of words we've got to think about here. If we're talking about a factor, it means a number that divides into the other number and gives a whole number answer. For example, 30 divided by 1 is 30. As that gives a full integer answer, a whole number answer, 1 is a factor of 30. We now have to think about if 1 is prime. Can we remember the rules for what a number is if it's prime? A number that's prime only has two factors, 1 and itself. Now 1 has the factor of 1, but itself is also 1. Therefore 1 is not prime. So it is a factor, but it's not prime. 2, let's have a look at 2. 30 divided by 2 is 15. 15 is an integer answer, a whole number answer, which means 2 again is a factor of 30. Now is 2 prime? What are the factors of 2? 1 times 2 is 2. 2 has got two factors, 1 and itself, therefore it is prime. Is 3 a factor of 30? 30 divided by 3 is 10. Yes, 3 is a factor. Let's now have a look if it's prime or not prime. 3 only has the factors 3 and 1, which means it only has two factors, 1 and itself, so it is prime. 4. 30 divided by 4. Now when I'm doing this, I might count up in my 4 times tables to try and see for some help. 4, 8, 12, 16, 20, 24, 28, 32. 4 does not divide evenly into 30 or give an integer answer, therefore it is not a factor. It would give a decimal answer. 5. 30 divided by 5 is 6. A 6 is a whole number, it tells us it is a factor. So we look at 5. What are the factors of 5? Yes, I think there's only 5 and 1. 5 is a prime factor. We look at 6. We do 30 divided by 6, which gives us 5. 5 is a whole answer, an integer answer. Therefore, 6 is a factor of 30. How many factors of 6 can you list? My factor pairs were 1 times 6 makes 6. 2 times 3 makes 6, which means 6 has got 4 factors, not 2, and therefore it's not prime. 10. 30 divided by 10 is 3. 3 is a whole number, so therefore 10 is a factor of 30. And now have a look at 10. Could we please list the factors of 10? I got the factors of 10 as 1 and 10, 2 and 5. 10 has got 4 factors, so therefore it's not prime. 15. 30 divided by 15 is 2. So 15 is a factor. What are the factors of 15? Could you please make a note of that? I got the factors of 15 as 1 times 15 make 15, but 3 times 5 also make 15, meaning again it's got 4 factors, so it's not prime. It's a non-prime factor. 30. 30 divided by 30 is 1. So yes, 30 is a factor. However, 30 has got all these factors, so we know that it's not a prime factor. When we try and work out what the product of primes are for 180, in order for us to do that, product in maths means multiply or times, and prime means that it's only got 2 factors. Factors are a number that build up or break back down that number, and that's what we're looking at here. So I'm going to start off asking for any 2 numbers that multiply to make 180. I don't want to use 1 times 180 because I'll just keep repeating myself. So here I'm going to go for 2 times 90. 2 multiplied by 90 is 180. I now have a look at the number 2. 2 only has 2 factors, 1 and itself, therefore 2 is prime. I now look at 90. What numbers multiply together to give me 90? What are 2 factors of 90? 2 times 45 make 90. 2 is prime, so I move on from 2. And now look at 45. What number is a factor of 45? I'm going to do 3 times 15. 3 is prime as it only has 2 factors, 1 and itself. So I now look at 15 and I break that into its factors of 3 and 5. Each of these numbers, 2, 2, 3, 3 and 5, are the key to working out what our product of prime factors are going to be. Product meaning multiply. I need to multiply each of these together in order to make the 180. If I multiply 2 times 2 times 3 times 3 times 5, the answer I will get is 180. With that in mind, let's look at a reasoning question. A student is asked to express 63 as a product of its prime factors. On which line does the first error occur? I think some of us may have noticed here when looking through and trying to figure out what the student has done wrong, that 9 multiplied by 6 is actually 54, not 63. The correct answer they should have done is 9 multiplied by 7. They've also made another mistake. I don't know if any of you were able to notice that. In their answer, they included 9 as a prime number. 9 has 3 factors, 1, 3 and itself, therefore it isn't prime, and we would in fact have carried on and split the 9 into 3 multiplied by 3. Here there are 3 different factor trees for 60. Could you have a look please and figure out which one of them is correct? If you have a look at A, 2 multiplied by 30 does make 60. 2 multiplied by 15 does make 30. 3 multiplied by 5 does make 15. The first one indicates 2 multiplied by 2 multiplied by 3 multiplied by 5 makes 60. The second one shows two different factors, 5 and 12. Then they've split 12 into 3 and 4, and 4 into 2 and 2. What do you recognise about the final answer for B and A? Both B and A have the factors 2, 2, 3 and 5. Here for C, again I've got the answer of 2, 3, 2 and 5. Each different method, as it's using all the factors, has still given us the same answer. Therefore, the final answer is D. A, B and C are all correct. Well, Year 7, I hope that you've had a wonderful maths lesson today, and I'm looking forward to seeing you all very soon. Thank you very much. Bye-bye.